Hi folks, in this video I'm going to give an overview about containers. I'm going to go over what it is, how we're using it, and a little bit of why we're using it. So we went over Git, and Git is able to track our application code. Alright, so the source code relating to application. But for containers to run, they also need libraries, right? Multiple libraries. Library number 1, library number 2, all the way to library number n. And so that we kind of lump together as the environment. So this is the environment that our our application runs in. And this environment is what containers are meant to track for us. So we updated library 1 from version 1 to version 2. The container will kind of encapsulate that environment and update it. Whichever code we're using to install library 1 version 1 is going to be updated to install library 1 version 2, and that's the environment. So the last thing we'll add into this picture is all of this lives in our host machine. So this is the Mac or the Windows or the Linux machine that you're running, the physical machine. Okay, so an analogy for this is that the host represents the entire world, and we'll say that you, the person, is the application, and the environment that you're in includes the weather, rain or wind, and the people that you interact with. So that's the environment that you're in. And if there was another person, he or she might experience a different kind of weather and be surrounded by different people. Okay? But if we kept to the analogy, we're just going to worry about you yourself. So in life, it's good to kind of not control the environment. So you leave things to be magical, and if everything in life you have to control it, then it might be a boring life. But in software, we want to control our environment so that we can run our application and it'll operate exactly the same way as we anticipate each and every time. So hopefully that explains what the container is meant to do for us. So I'm gonna try to explain this. So hopefully that explains what containers are supposed to do for us and why we want it that way. And then now I'm gonna go into a little bit. We're gonna explain containers again, but also maybe like how it came about. So it all started, in the beginning, we had physical machines, and again, these are what you're using. your laptops, right? Something you can touch, or desktop, your laptops or desktop. It could be a Mac, Windows, or Linux. And when we serve applications, we normally have these machines run 24/7, 365 days in a year. So they're kind of optimized to be on all the time. So you have these server racks, and to add more machines, you just add more hardware. So physical hardware you can touch, right? So there's gonna be, let's see, each machine will have its own CPU, RAM, and hard drive. And if you want another machine, you have to get another set of CPU, RAM, and hard drive. So each time you want a new one, you have to physically buy one and kind of install it. So that was a little bit tedious. So the next generation was virtual machines. That's what this is here. And it's basically one physical machine, and inside it you can run different operating systems. Here you can see this is Windows 8, this is Windows 10, and this window here is Linux. All inside one host operating system, which is kind of like the OS of the physical machine. So were to draw this out, it would look like this. So again, we have the physical machine, and in it we are, let's see, in it we have a virtual machine, or multiple ones. So VM is short for virtual machine. And they're going to share. So all these virtual machines, they're going to share the same CPU, RAM, and hard drive on the physical machine. Individually, they'll have their own operating system, right? So that's the next generation of virtualization, right? First, it was the physical machines as the first generation. The next generation was virtual machines. So with one physical machine, we can now have multiple virtual machines to better utilize under-tapped resources within the physical machine. So now containers is kind of the third iteration of this virtualization idea across this timeline. Okay, so again, we're gonna have our physical machine, and then within it we'll have a virtual machine, and then within that we'll have our container, and each virtual machine can run multiple containers. So let me just erase this. Make it a little bit longer. Okay, so again, there will be, if there's multiple virtual machines on this machine, they'll be sharing CPU, RAM, and hard drive. And all the containers within this virtual machine will be sharing the same OS. And then within the containers themselves, you have the application and its dependencies. So same thing, each container will have an application and their dependencies. So that is kind of the next progression of virtualization. We have these virtual machines, sometimes they're underutilized, and it's good to kind of share resources of the OS across multiple containers. Now, because these virtual machines are no different from physical machines, we could just run containers on the physical machine directly, right? And in this case, they're just going to share the physical machine's operating system. And each container will have its application and its dependencies. So if you want it to be super secure, you can isolate your physical machine with a virtual machine. But for this class, we're just going to have this setup where we run our containers directly on our host machine. Okay, so hopefully that makes sense. And that's kind of what we're going to try to do with containers in this next section of the course. All right, thank you for watching. And I hope you understand why and how we can use containers, and hopefully you'll enjoy using containers because they're really nifty tools. All right, thanks again. Bye.